Hi, Tom English again, and I want to wrap up the lesson on trigonometry with a couple special triangles. And why I call them special triangles are you're going to run into them time after time. And if you can get these down and actually memorize them like you should have your times table and so forth, you'll be a lot further along, and I'm sure we'll score higher in the test. The two special triangles are what's called the 45-45 degree triangle and the 30-60 degree right triangle. If you look at the 45 degree triangle, hopefully you recognize right away, well, that's just half of a square. And if you remember the square, of course, all four sides are the same, so I indicated the side as S. And then through the Pythagorean theorem, you find that the diagonal of the square is S times the square root of 2. And knowing that, then what I'd like to do is calculate the sine, cosine, and tangent of those and see if you can lock those into your memory. Again, the sine is the opposite over the hypotenuse. The side opposite is S. The hypotenuse is S over the square root of 2. The S's cancel, but we can't have a square root in this denominator, can we? So we multiply by the square root of 2 over the square root of 2. And so therefore the sine of a 45 degree angle is equal to the square root of 2 over 2. The cosine, well, in this case it's the same, isn't it? Because the angles are the same, the sides are the same. So that's also equal to the square root of 2 over 2. And the tangent is even easier. The tangent is what? The opposite side over the adjacent side. And in this case it's S over S, so that's equal to 1. So let's put these up, and this is what I'm hoping that you can lock in on and commit to memory. So the sine is square root of 2 over 2. The cosine is the square root of 2 over 2. And the tangent is equal to 1. All right, let's do the 30-60 degree triangle. The one thing that, again, by doing the Pythagorean theorem, we know that the side opposite the 30 degree angle is 1/2 of the hypotenuse. So if we say the side opposite is x, then the hypotenuse would be 2x. And using the Pythagorean theorem, we find the third side as x times the square root of 3. Again, knowing that, let's fill in the blanks here. The sine is opposite over the adjacent. So we have x over 2x. The x's cancel, so that's equal to 1/2. So the sine of 130 degrees is 1/2. The cosine. The cosine is what? The adjacent over the hypotenuse. X times square root of 3 over 2x, the x's cancel. We end up with the square root of 3 over 2. The tangent is opposite over the adjacent. We have x over x times the square root of 3. Again, we can't have a square root in the denominator, so we're going to multiply that by square root of 3 over square root of 3. And our answer then becomes square root of 3 over 3. And finally the 60 degree. Again, the sine, we're looking at this angle, so it's opposite over the hypotenuse. X times the square root of 3 over 2x, the x's cancel. Then we just end up with the square root of 3 over 2. And the cosine. The cosine is the adjacent, x over 2x. That becomes 1/2. And finally the tangent. The tangent is what? The opposite over adjacent. X times the square root of 3 over x. The x's cancel, and we just end up with the square root of 3. Okay, looks like a jumble up there, but if you take them individually, the tangent, or the 45 degree, both the sine and cosine are square root of 2 over 2. The tangent is 1. You notice the sine of 30 degrees is equal to the cosine of 60 degrees. And it's just the opposite. The cosine of 30 degrees is equal to the sine. So notice that those two switch, and it's a little easier, or they're counter to each other. And then finally, the last one's for the tangent. Again, you're going to face those over and over again. You can calculate them each time, or you can kind of lock in that little table to your memory, and hopefully you'll do much better on your test. That's it for trigonometry. We're going to move into quadrilaterals next, maybe get into some solids, talk about volumes and areas and so forth, and hopefully we'll wrap up geometry in a few more lessons. Thank you much.